Welcome, everyone. My name is Christopher Logan, and welcome to Building SaaS on AWS. This is the show where we talk about the innovations, the best practices, and any of the hows of how to build SaaS on AWS. We have a spectacularly special show today. We have our first Korean guest and an amazing company in Asleep. So by way of first introductions, we have co-founder and head of development for Asleep, Aaron Koo. Welcome, Aaron.
Hello, I'm Aaron, and I'm the co-founder and currently head of development here at Asleep. To give you a little background how I got into this exciting sleep tech industry, prior to Asleep, I started out my career as an embedded software developer, doing missile guidance systems R&D in Government Research Institute. And I started Asleep with my friends from grad school about 2 years back. And when we first started, I was mainly on the R&D side. And when we decided we were ready to start building a product, I then took on a software development role and designing and implementing our software product. And as we scaled our team, I'm now mainly responsible for managing the entire development team. And really honored and excited to be on the show today with you guys. Definitely looking forward to our conversation.
That's wonderful, Aaron. Thank you so much. That is a phenomenally exciting start to a career with also a spectacular company as well. We also have with us Sungmin Kim, AWS AI/ML Specialist Solutions Architect. Welcome, Sungmin.
Hi everyone, I'm Sungmin Kim. I'm a solutions architect in AWS in Korea. I generally work with startup in Korea, and especially I help customers with the AI/ML workload or analytics workload. Thank you.
Lovely. Thanks for joining us. So, Aaron, we would love to understand, and I'm sure our audience would love to understand more about Asleep, what it does, how it gets used, and all of the wonderful highlights of your amazing company.
Okay, so we Asleep is a sleep tech company, and we provide medical grade sleep tracking AI solution to improve people's sleep health at home. And the current problem, is that sleep is really a big market. A lot of people face severe sleep problems, including myself. And one interesting stat to note is that according to World Economic Forum, 4.8 billion adults face sleep problems. So it's definitely a problem that's existing in the market. And we want to utilize our AI technology to solve this big sleep problem. And to do that, we use audio signal as a key biosignal to identify sleep stages. And we've developed our AI model using, like respiration and movement sound during sleep, as input, and then our AI model takes that sound signal as input, and then it can classify like the sleep stages. Yeah. And then like beyond that, we offer that sleep data to end consumers or businesses or to even hospitals. And essentially at the end of the day, we want to position ourselves a sleep data company. So overall, so we want to solve this big sleep problem with our core sleep AI technology. Yeah. And maybe to give you a better idea of what kind of service we can offer, I'll show you a short video of our open beta mobile app named Sleep. It's a very short video, so
have a look.
Yeah. So here, this app is recording your sound, and then it does like internally, it's doing some kind of like pre-processing, and then it will send that signal to our server, like through our API product. And then our server like runs the AI model and then analyzes signal, and then after you wake up, it issues this kind of sleep report of the night. Yeah, so this is like one use case of our API product. Yeah. Yeah,
That's
that would be
awesome.
it. Yeah.
Look, so Aaron, the audience here is mostly technical engineers, infrastructure people. So what would be awesome to see is what powers a sleep? What is the technology behind it? That would be fantastic intro. So people get an idea of how you build this.
Okay, so yeah, so the main topic of today's show is our API product and how we implemented our metering system. So our API product called Sleep Track API, and Sleep Track API provides sleep data to businesses to improve their customers' sleep health. And the core and the essence of our technology includes, like I said before, sound signal and AI technology. So the major condition you need to have to work with us is that you just need to have microphones inside built in your device. Yeah. So, like for example, we're working with key smart device players like smart speaker companies or smart watches, smart TVs, smartphones. And maybe to give you a specific use case, we've recently been selected as an Amazon Alexa startup company. So we've been
Awesome.
working closely with the relevant teams, for partnership opportunities. And
Yeah, that's brilliant.
so with our product, our partners will be able to implement the sleep tracking, sleep analysis capability in their smart devices. So and
That's
so essentially, like we want to become the hub or the center of the sleep data, like based sleep data based personalized bedroom environment by partnering with smart device companies through our API. And then maybe beyond providing just sleep data to our business partners, we're also developing a feature that provides our partners with, so we can help our partners understand what they need to do with the data to actually implement a service that could lead to actually improving their customers' sleep health. So we care about not just numbers, or rather what you actually need to do with those numbers and to improve your sleep health. So providing so what solution is what we think is very important and what we're focusing on right now as a next step.
Okay, it's very interesting. But by the way, I have I think that the smartwatches do the same things. So I wonder what makes your product is different compared to them.
Oh yeah, great question. So like I said, because we use just sound for sleep tracking, you don't have to wear anything during sleep. So no additional sensors are needed. It's just the microphone inside your smartphone or smart speakers, etc. So the convenience aspect, like in terms of like tech integration or usability, is that watch you have to wear during sleep, and with us you don't need to wear anything. So it's fully contactless. And maybe like another possible limitation to the smartwatches is that like many people charge their smartwatches overnight, and if you put on your watch during the time, and then you're gonna have to devote some of your extra time to charge it, when you're awake during the day. So so we took care of that problem, knowing that like in contact devices have limitation like that.
That's exactly so. So I have an Apple Watch.
Oh, cool.
It's the issue. The battery lasts until the end of the day, and then I'm like, it has to go charge. So there's no way. Like I have a sleep app on the watch that never, ever, ever gets used for that exact reason.
Yeah.
So have you used the sleep tracking function on the watch?
Well, I don't, because Like I can't wear it when I'm asleep. Like it has to
Sleep well?
charge. Otherwise, during the daytime, like it needs to be on my wrist during the daytime, which means the battery's gone by the time it's
Yeah.
bedtime.
Yeah, exactly. So we use just sound, and actually we believe sound signal is it's enough, and then we believe that sound is the next home sleep test standard and has a big potential and scalability.
Yeah, that's awesome. So, are there any privacy issues with recording like the sound during sleep?
So yeah, that's a very, very important issue. So like actually we get that question a lot. And lots of our partners and even internally ourselves, we extremely care about privacy issues. So like actually we don't directly use raw audio signal as the input for our AI model, but we use what's called Mel spectrogram, which is basically, you can think of it as some kind of like image representation of the sound. So
Yeah.
and and to convert the audio signal to Mel spectrogram, it's a lossy transformation, meaning that you cannot like recover the original sound from it. So with this, we can remove the private information from the original data, but still keep the essential information we need to fit into our AI model to analyze the sleep. So yeah, so one thing you can do is you can implement this Mel spectrogram conversion on your device, and then send the Mel spectrogram only to our server.
Oh, that's awesome. That's a great answer. So would love to see what the architecture looks like on this. Shall we have a look at that?
Okay.
Let's have a look.
So I'll just briefly cover the overview, and then we're gonna get to the metering part. So this is the high level architecture diagram of our service with the focus on the metering pipeline. And as you can see in the upper part of the diagram, there's a set of resources that make up the actual sleep analysis service, including like providing sleep data and some machine learning related stuff like AI inference or AI model management service. Then
I wonder if you train the AI model. So, how do you deploy your AI model into the sleep analysis services?
I'm sorry, you asked like how we deploy a
Oh,
new
yeah,
model into the
yeah,
server. Oh, okay,
yeah,
okay.
right.
Yeah, great question. So like if you are doing an AI service, like if you're serving an AI model, like with the new data coming in, it's very, very crucial to be able to like continuously retrain your model with the new data and update the model with a better one. So to do that, we are using what's called MLflow internally, which is an open source platform for managing the development cycle of ML product. And so like once the training is done, and if we decided to update the model or deploy a new model, our AI team registers the MLflow packaged new model into the model registry that we built. And then our inference server, which does the AI processing, fetches and loads the new model during runtime. So, for example, we have a number of models available which provide different functionalities or features, and our client can make a request to use a certain model according to their subscription plan, and then we don't have a dedicated server for serving just a certain model. All our inference server can serve like all models, so it's a multimodal like inference server. And then if when the request comes in, and then the inference server checks the parameter for the model name or model version, and if it doesn't have that certain model on the instance, then it just fetches from the model registry during runtime. So would that answer your question?
Yeah, that's good. Yeah.
Yeah, that's great. Aaron, can you talk a little bit about how you're using the API gateway and Lambda there?
So yeah, okay. So because our product is an API product, we expose our service through API gateway or REST API, and so we use this Lambda authorizer for authentication or authorization. So like all the authorization happens here in this layer. And what we do for access control is we do API key based access control. So like the basic role for Lambda authorizer is that like it checks if the API key is valid or if it has the right permission for the request. So yeah, so that's how we implemented the access control feature.
So
Interesting.
yeah, but
Yeah.
that is interesting. But I just wonder, in AWS we have the authorizer service like Cognito, but you use the Lambda to implement the custom authorization. So why you choose the Lambda to implement your custom authorizers?
Okay. Why did we choose to use Lambda, like custom Lambda authorizer instead of
Yeah,
other
right.
options available, right? So Lambda authorizer was the most flexible option. Obviously you can implement any logic, any access control logic. So like for example, like you just said, you can directly use the Cognito user poll as an authorizer if you want to do a token based access control, like with ID tokens or access tokens. But what we wanted to do was we wanted to do API key based access control with our custom access control logic. Like for example, we have a number of AI models, like I just said, and our various models can offer different features. Like, for example, there's a model to classify sleep stages, or there's a model that can tell if a person snores or even has a sleep disorder, like sleep apnea. So, like according to what plan you subscribe to, we control like which model or like which endpoint you have access to. And for us, Lambda authorizer was the best option.
Oh yeah, thanks, good, thanks.
Aaron, so one of the things that we do want to touch on in the show today is understanding usage and your users. So how do you understand what your customers are doing and how many requests are going through that system to then make future decisions?
So yeah. So we use this API gateway's access logs as the source data for counting or metering, and eventually we use Amazon Athena and using Athena queries on these access logs to calculate usage statistics. So in the API gateway, you can customize access logging. Like, for example, you can choose like what to log in which format, and we configured the access logging to record the information we need, like for example, request time, or request path, or HTTP status codes, or API key, and in JSON format. And then these JSON logs end up in S3 buckets through Kinesis Firehose. So like with this, we just need to analyze these log files, to count how many requests were made from each API key. But you want to do it efficiently, right? So because like you might have like millions of records coming in a short period of time. So you want to make it efficient. So maybe here, I'd like to share some code, that we actually
Sure.
use, show you how we try to go about it.
Yeah, absolutely.
So I'm gonna be sharing my VS Code.
There we go.
Yeah, can you see that? Can you read read it?
There we go. That should be big enough, I think.
Okay. So this is the actual Python script that we run for analyzing the log data, and then what we wanted to do, the requirements was to do hourly metering. So we run this script on Jenkins every hour at 10 minutes, and I'll tell you why it's not on the exact hour, in a minute. So
Mhm.
to briefly explain like what this script does, like it transforms the JSON data or the original log data into a more efficient format called like Parquet, and then it runs Amazon Athena query to calculate usage information like on that Parquet data, and then it will insert the query results into database where we store the usage data. So yeah, so let's take a look at the code. So here, this function, this add partitions function, what it does is, because it's hourly metering, we partition the data on hour, and to do that, first we have to add a partition containing the logs in the current hour, in the most recent hour. And internally, Amazon Athena uses what's called glue, and it will make an intermediary glue table, which is basically a metadata table or data catalog for the original JSON log data in S3. And then this is the Athena SQL statement that we use to add partition. And if you look at the code, we are actually adding partitions 3 times. Like there's a for loop statement, and then we actually add 3 partitions for the previous hour and the current hour and the next hour. The reason is that this is a simple like fail-safe trick. Like with this, we can effectively get to try adding a partition 3 times for each hour, so that like we can have better chance to make when a run gets failed. So yeah, so
Right.
this is like a pre-step to run the actual like calculation.
Mhm.
So after adding the current hours partition to the glue table, what we do next is this one. So yeah, this is the next function we run, and after adding a new partition to the table, we run a ctest query or create table as select query against the table, against the original JSON data table. And as the name suggests, it creates a new glue table, and only for the selected data. So this here is the actual ctest query statement we use. And here you can see that we filter data or select data, for the previous and the current hour. And the reason that we cover like 2-hour time span is that like some of the log records might end up in the next hour's partition, because we are using Firehose, and Firehose before it sends the log records to the destination S3 bucket, Firehose first accumulates incoming data until it hits the max buffer size or max buffer interval. So like some of the last second logs, let's say maybe logs at like 259 time mark might end up in the partition for 3. So
Right.
that's why we run this job like every hour at 10 minutes and select the current hour and also the previous hour, just to make sure we cover like all records of this full 1 hour time span. And another very important job that this C-test query does is that here we convert the JSON data into a columnar format. We're using Parquet for the columnar format, and it like by converting this, it makes the subsequent queries that we're going to be making way more efficient. Yeah, so we can boost up the query performance by like 30 to 40%. You know.
Oh, that's awesome.
Yeah. And then for the next step, so the next step, like after like selecting and converting the data into Parquet, and now we are ready to actually calculate the usage statistics for API key. So we're gonna make another Athena query against the newly created optimized Parquet table. So here's the function. So after a C-test query, we make another query like this, and by grouping API key and the path, what we can do with this is we can separately count like how many requests were made to each endpoint and from each API key, and that's what we want to do. So with this, so after we work out the numbers, and the last step is to update the RJs table, where we store the usage statistics, and we have daily usage and monthly usage table. So we have 2 tables for storing usage data. So we're gonna do like insert or update query into both of the tables. So yeah, so this is pretty much the only code that we wrote for metering, besides some of CDK codes. So like you can build this kind of pipeline with very minimal coding. So and then we are counting like what we're doing is we just count like how many successful requests were made from each API key. But like if you want, with this you can do more in-depth like performance analysis, like if you want. So I think it's a very, very easy to set up, very efficient, like fully managed, scalable like pipeline.
Yeah, that looks amazing.
Yeah. So you use the Athena to analyze the access row, but in AWS there is many other analytics services like Redshift or Glue or EMR. So I wonder why you choose the Amazon Athena other than services.
Oh yeah, great question. Besides Amazon Athena, what we have considered was like Redshift or EMR or Glue for the analytics service. But we decided to go with Athena because it had the very low learning curve and low operating costs. So we thought that it was the best option for us at the time. So to be honest, I don't know much about like other services like EMR or Redshift, but what I know is for EMR or Glue, you have to manage the clusters yourself. So, but Athena is serverless, so no need to manage clusters, and plus you only have to pay for the the actual queries you run, right? So it's very cost efficient. So yeah, so the basic theme for us was like most early stage startups, like we started out with a relatively like limited manpower compared to the scope what we wanted to build. So we try to leverage serverless or managed services as much as we can, so that we can focus more on our business values.
Oh, thank you.
Aaron, did you consider the API gateway usage plans in this?
Oh yeah. So we've yeah, I've we've looked at the usage plans of the API gateway, but we wanted more fine-grained metering than what you can do with usage plans. So for example, we wanted to separately count like how many requests were made per endpoint, or we wanted to count a certain set of HTTP status codes. And as far as I know, you can't do such things with usage plan. So we decided to uh, build our own metering system. And plus usage plan is mainly for like throttling or setting a quota limit like per API key. But our goal was mostly metering, like just to count like how many requests were made, so that we can later maybe charge our client based on the metering results, or implement like various types of subscription plans later. So yeah, that's why we didn't use usage plans.
Okay, very interesting. So this would be a great example to talk through how this architecture fits into well architected.
Yeah, this part, let me explain this part. Uh,
Mm.
Aaron, can you pull up the architecture again? Architecture diagram?
Okay.
Yeah.
So I'm gonna stop sharing my VS Code and then.
All right. There you go.
Yeah, thank you. So, in these architectures, Axlib user mostly Amazon serverless services as much as possible. So Axlib can keep operation cost and T-shirt as well as low as possible. So one more thing, since AWS serverless services are highly reliable, so that Axlib can also achieve high reliabilities. But uh, this architecture is a very low cost and high reliability architectures. Also, uh, in terms of cost optimization, Axlib also applies S3 data tiering. In As you see in this architecture, Axlib uses the two different type of data format, JSON and package. So they tiering the data by JSON and package. So Axlib can reduce the Athena execution query Athena query execution cost and S3 storage cost, as well as optimize the Athena query performance. Because Athena charge the cost by uh, how much it reads the data from S3, and then how long take time to execute the queries. But uh, if you merge the large number of piles into a large size, many small number of large piles, it then Athena can uh, execute queries very fast on uh, the large size and small piles. a small number of files. So Aslip's architecture is also well designed for performance efficiency. So finally, Aslip's system, I think that it is difficult for malicious users to break into Aslip because the architecture is mostly implemented with serverless services. So also, the RDS and Jenkins server is both deployed in the private subnets. So there is they are very secure. So overall, I think that Aslip's architecture is well architected, and many well architected framework best practice have been applied.
Yeah, that's super interesting, and well done to the team for creating something super awesome and following a lot of the war principles as well. So we've seen an architecture, we've seen the use cases, we've seen the code. We would love to see a demo, Aaron. That would be tremendous.
Okay, so to be honest, I'm not really sure I can if I can tell if I can call this a demo, but yeah, it's what I wanted to do was I wanted to try to show you how this metering is working by following the pipeline on the actual AWS console, but sadly that was not allowed because of some company policy. So what I have here instead is some of the screenshots of the AWS console. So before this show, actually I've started a script to make dummy requests for the sake of the demo. So lots of requests have been hitting the API gateway, and during the show, they must have been leaving a lot of access logs. But anyway, so this is the access logging configuration on our API gateway console. So we have enabled access logging, and then we configured and then set the log format like this. So including so this log format includes request time or HTTP method, request path, and API key and stuff, so that with this information we can later use them for metering. And actually besides these kinds of information, there are many other kinds of data that you can log. So if you want, you can choose like what to log and like in which format according to your needs. So you can see here, the destination of this access log is Firehose, Kinesis Firehose, and then here this is the Kinesis Firehose delivery stream console, and you can see there's incoming bytes from the access log, and believe me, it's coming from the access log, and then eventually, these logs get to be sent to S3, and then like this. So, for the bucket prefix, we have chosen to use Apache Hive style partitioning format, where the path has the names of the partition and their values. So since Amazon Athena supports this kind of format, you can very easily partition on the data with Athena queries. So here, this is the S3 console. So here you can see JSON log files getting piled up, accumulated in S3 from Firehose. And then you can also see how we use here Apache Hive style partitioning format. And You can very easily set up a pipeline like this, which is very, very scalable, fully managed. Like I didn't do any coding. I just like touched some of the configuration, and that was it. And then after this, like I showed you, like in the code before, so we run a series of Athena queries to calculate the usage statistics against this raw or original JSON data. First to convert them to Parquet, and then next to actually calculate the usage statistics. So so for the actual to show you how we actually store the usage data. So here is the sneak peek of our DB table. So here we count like for each API key and for each day, and like for like which type of endpoint our client used. We're all separately counting the request number like this. So this is the daily usage data. And then we have another table for the monthly usage table, monthly usage data. So, and this is what we mainly is using, what we are mainly using for the charging, or for the charging our clients. So yeah, so that would be a quick run through of the pipeline.
Awesome. So we are getting near time. There is a question about how do you start using a Sleep? Because you're still in early stages of some of that. So if somebody wanted to go use the API, what's the step?
So right now our product, Sleep Track API, is actually fully functioning, and it's a well working product, but we haven't decided. It is not publicly available yet. So currently we're doing is we're doing a number of POCs with various different strategic partners. And while we are working on like final steps to launching the product, like for example, building a developer dashboard and stuff, and we're planning to officially launch in the near future. So if you're interested, actually I have a link. So
yep, I can put that.
Could you share that?
Yeah, I can show one sec. Okay.
Great.
So that is the link for a partnership request if you are a business.
Right. So if you're interested in learning more about the product or discussing collaboration partnership opportunities, you can check out the link.
Awesome. Well, look, we have gone through everything we have time for today. It's been an absolute pleasure. There's been some tremendous insights into both your architecture and your use cases, and how well this product and this service is architected, and the use of things like Athena and API Gateway and Lambda Authorizer has been tremendous help. So thank you, Aaron. Thank you for coming on. Thank you for introducing us to A-Sleep and its technology. It's been an absolute pleasure.
Okay, so maybe I saw a question on the chat.
Yeah.
Maybe I can. Yeah. Maybe can I answer the question?
Sure, I'd love to. Yeah. Let's read the question out. Do you want to read that out?
Oh yeah. So actually, there are two people asking the same question. So So they're asking about like how we do like how we can apply our like sound-based AI technology if for two people sleeping, you know.
Sure.
Yeah, so actually that's a very, very good question, and we get that a lot. And so at first it can seem a fundamental like limitation to all like contactless sleep tracking technology. And actually there are no like commercialized sleep trackers like using contactless technology for two people sleeping. So
Mm.
there are no product like that out there. But what we believe is that at least in theory, we believe that we can separate audio signals from two people in bed together. And we're currently actually designing the experiments for that. And I cannot tell you much about this, but at the moment, we were designing the experiments. We have our own like experiments, like test bed and the hospital relationships to do that. So it's definitely on our roadmap.
That would be very interesting. That would be very interesting, and definitely first to market for that sort of stuff, which would be super cool. Thanks for that, Aaron. Okay, I think that is what we have time for today. So thanks again, Aaron. Thanks, Sungmin, for joining us. Awesome show. If there's any other questions post this, feel free to DM me on Twitch, and we can get those answers to you. Thank you for everyone that was on the chat. It was awesome to see. And we'll be joining you again in 2 weeks. So thank you again, Aaron and Sungmin.
Thank you.
Thank you for inviting us.
Bye.
You're welcome. All right. Thanks, everyone. See you next time.